Well, good morning. We'll be going live in just a few moments. I hope you're all doing okay out there. Hope you're not getting too stressed if you're shut in the house at the moment. But as I say, I hope whatever circumstances you're under, everything is okay. Anyway, today we'll be looking at the Spectrum Next. We're going to try and port the little Yquest game to the Spectrum Next and see how that goes. So hopefully it'll go okay. I don't know. All I've done to prepare for this is I've converted my joystick smiley routine from the Simple series to the Spectrum Next, and I'll be doing videos on that very shortly. Apart from that, I've been working on the 6809 tutorials this week. They're all written now, just the text, not the videos yet, so the videos will come after the PDP-11 and the TMS 9900 series are done. But that's sort of just getting ready for that. And I've been looking at the Vectrex yesterday, because that's a 6809 system that I think will be a lot of fun to try and add to my list of systems covered by the tutorials. So that's my plan anyway. What time is it? Oh, yeah, well, there's no point by hanging around. Let's go over to our programming window and start with our programming. There we go. Okay, good morning, Mark. It's very kind of you to join me today. So we're going to be doing Spectrum Next version of Yquest, hopefully, if everything goes okay. So if I just fire this up here. Oh. I hope that noise isn't, it's making a lot of noise. I hope that's not recording. Okay, so here's the smiley, oh, what's going on? So here's the smiley face, and we can move it around the screen with the cursors here. So I had to write I had to convert my smiley face routine for the Spectrum Next, the sprite drawing routine, and also I'm using a different key reading routine rather than using the firmware. I'm going direct to the hardware now because the firmware one was too slow. I was only reading once per frame, I think, basically. So now I'm reading in from the hardware directly. And that gives me the speed. That's what we want. We want that speed. Okay. So we need to get Yquest, and we want to base this on the Sam Coupe version, I think. So if we just do a save as here and do a ZXN, which is the 3-letter abbreviation I use for the next. Okay, so we want to have these. These are for the Spectrum Next CPU has some commands added to it, so it's got some opcodes that don't exist typically, and so that's to support those. Yeah, here's the stuff to turn on the screen here, so we'll crib that. Don't need this side. We don't need that. So if we get rid of all of this. Sam Coupe was also based on the ZX Spectrum in a lot of ways, so it's kind of ironic somehow. Anyway. Okay, so we need some kind of palette. Do for starters. Now we need to redo these. These are going to not be correct. We need these to be 1 byte per pixel, which we can do. The Yquest editor will do that for us. If I just get Yquest editor up. Hang on a minute. Sorry, just Yquest editor. Here it is. Here's Yquest editor, and if we okay, and no, Spectrum Next is a separate one, isn't it? Save next palette, copied to clipboard. Okay, and then if I just paste this in here, there we go. So that should be the palette. So we're gonna go through this in stages then. So first of all, we're gonna try and get the. I'm on the wrong one. Oh fuck! I'm on that joystick one, not this Yquest one. That's not right. Okay. Label print space redefined. Yeah, okay, that's no problem. I changed the code. I'll move that to the common routine. Not sure what happened there. Okay, yeah, I do. We've got to copy our drawing routine, so I'm going to take that. No, that's very loud and annoying. Okay, should do. The Spectrum Next makes a lot of noise, and there's something wrong with my my build script as well. It should close itself. It's not. Okay, so I need to copy this code here. Is that it? Okay, I guess it's very small. Yeah, I'm using LDIR. And I guess we just want to replace all of this then. Although I need to put a pop BC in. Notice we're using IX again. We got caught out like that before, so you need to do the push IX here. LDIR is using B and C, you see. I need to take this get next line and this get screen pass. Hello Lucas, very kind of you to join me today. We're doing Spectrum Next today. You may be interested in the keyboard reading routine of this. We'll have a look at it in a moment, because the keyboard reading routine of the Spectrum Next is very, very similar to the one on the MSX, and it's the same on the Amstrad CPC. For some reason, most of the Z80 systems use the exact same key reading routine, even the TI 83 calculator. Just very slight changes to the way it works. The concept's the same, I mean. So might be of interest to you. It doesn't look very good, does it? Well, we'll worry about that. I'll worry about it in a moment. Okay, so pushing IX there, popping IX there. Hello there, Quasar. We're looking at the Spectrum Next today, and I'm far too tired to do this, I think, today. We'll get there, though. We will manage it at some point. I mean, with all of these, even if I don't manage them during the episode, we'll finish it anyway after the episode. I'll do it in the evening. So we're always going to end up with a finished game at some point. Look at that mess. What's that all about? I have no idea. Unfortunately, I have no idea. Well, that's a shame. I get screen pause and I get next line here. Okay, well, let's go through let's go through this a step at a time here. Let's put this after the palette loop. Maybe the palette loop might be messing up. Okay, so the palette loop is not messing up. Although that needs to be 16 now, because I've got 16 colours being defined. This code is turning on the screen. That's speeding up the CPU. I don't know if we need the CPU speeding up, but we'll have it. Hang on a minute, where's the origin statement? Oh, did I accidentally remove the origin statement? Well, that won't go very well. Put that in there. We're using the 256 color mode here, which is probably going to be rather excessive for this example. I'm hoping we're not going to run out of memory with regards to all of the sprites, because if we're using 256 colors, then that font's going to get pretty big. But we'll see how it goes. Aha! Okay, so we're getting somewhere. So we got some garbled stuff there. Okay. So just checking I'd actually updated this program, because there was a bug in it. I couldn't use next and last bank last time, so it looks like I did get around to fixing that. So if we go to spec next here, say for 8-bit per pixel bitmap, and we do ZX N Yquest raw next bank, sorry, and we'll just keep. I mean, it's got a decent spec. I mean, the 256 color screen is pretty unrivaled for Z80 systems. The Commander has one as well. It feels slightly excessive, I mean, 16 colors I think is pretty adequate for 8-bit. But I mean, yeah, it's got lots of layers. It's got a variety of options. It's got the hardware sprites, although they're a little bit. I did try, and I was trying to write a tutorial on the hardware sprites, but they added 4-bit per pixel sprites late in the development after the first few releases, and I don't think the emulator I'm using supports them yet. So I'm waiting. I will do it when they. It looks like the X16 when they finish changing the firmware functionality. I fixed the bank bug. The bank button bug. Sorry, I don't understand that, Mark. Sorry. Oh, that. Yes, sorry. Yes, I do. Yeah, sorry. I was thinking Spectrum banks. Yeah, sorry. Yes. Yeah. There was. The code I did for the true color support. There was a bug crept in, and I think it was a bit of test code got left lying around or some nonsense like that. So yeah. I need to start trying to figure out how I'm going to do Vectrex graphics, because I'm covering the Vectrex as well. I was playing with the Vectrex yesterday evening, and I drew a vector graphic. Well, I didn't draw it. I calculated in my head the sort of movements, and I drew a little square with a line in the middle kind of thing. So I'm thinking like maybe I need to try and sorry, Mark. Sorry, I was being slow. Apologise. Yeah. So yeah, I need to get it in there, don't I? It takes so long to update everything for the website at the moment. Okay, let's see what we've got here. Okay, so yeah, we got the sprites. The sprites are looking good. However, I need to double the calculations. Okay. Yeah, the only Vectrex I ever had quite on. I got one from a jumble sale, like a brick and rack thing, and I paid about £2 for it, and it didn't work, and it was beyond me to fix it, so unfortunately got chucked out. But it was all rusty inside, so it wasn't surprising it didn't work. But I've heard one. I had one, but it never played one, which is a shame because it's a very interesting system. It was basically the reason I started looking at 6809. I wanted to have a go with the Vectrex just because it's so unique compared to the other systems that I cover, and the other systems in general. It's the only one that works like that. So yeah, as I say, I'm looking forward to that. I think it'll be a bit of fun. There we go. I don't know what's going on with that mouth. I don't understand that. What's going on? Oh, okay. It's the mathematical routine. It's miscalculating the tile numbers because okay. Yeah, it's all right. I need to change this routine as well, and I need to add another. I need to remove one of these because the sprites are twice the size that they were. That's why. That's why it's miscalculating the memory offset. There we go. So we've got a logo there. I think that looks all right. So our sprites are getting onto the screen, and we've not run out of memory yet. We possibly will. We need to do that font as well, don't we? Let's get that font done now. So if we where's the font? There it is. And if we do File, Spec Next, Save raw 8-bit per pixel. Font NXT. Okay, where's our font code? Somewhere around here. There it is. Hello there, Space Paranoid X. We're trying to port my little Yquest game to the Spectrum next. So that's the mission of the day. Should I choose to accept it? Unfortunately, it seems I have chosen to accept it. So let's just hope I don't make too many coding bugs this morning. Okay, well that didn't work very well. There's garbled nonsense all over the place. Well, I'm sure we can fix that. I'm assuming I selected the right export option. Well, we'll look at that in a moment. I'm sure I need to change the print char routines. So we need to remove one of these. We also need to increase the That's because we're using twice as many bytes for our font characters. Yeah, I believe so. Space Paranoid X. I didn't, to be honest, until I was reading up on it yesterday. I didn't realise it was released in Japan, so I guess that would be a yes. I have seen a store in town selling a Vectrex for an obscene amount of money. However, I don't know if it's the Japanese one or an imported one, so I can't comment on that. Okay, so our font's sort of in the right place, but it's all nonsense. I wonder why. Let's just check. Maybe I selected the wrong export option here. So Spectrum next. Oh, hang on a minute. Whoa. Oh, I need an option I don't have. I need to save 8 bit per pixel 8 by 8 tiles. I haven't got one. I need to break it up into 8 by 8 chunks, and I don't have an option to do that. Do I have another one I can use for the same function? No. This might do it. Save 8 bit per pixel, 8 by 8 tiles in the Commander 16. I think this will be okay. I think this will do it. Let's give it a go. Yeah, I think it might work. That's the advantage now of Yquest Byte Editor supporting so many systems. Often when I come to use a new system now, it already actually supports what I need. Well, the colours are wrong on the font. Oh, okay. Yeah, okay. I think I need a better font. Yeah, I exported the wrong font file. Okay, so let's try again. Commanders, yeah. Well, I mean, they're both very comparable, aren't they? The functionality that they're trying to provide is kind of similar. You know, they both support modern color systems and modern tile sprite systems and things with a classic processor. It's just the choice of classic processor is different, really, isn't it? There we go. There's our font. That font's okay now. Right. So where's our clear screen routine here? Here it is. Oh, that's going to make a right mess. We'll take that out. Okay, I'm just got to think how I'm going to do this. Yeah, I agree, Mark. Yeah, you're right. Okay. So if I load in BC with 0 here, so that'll select the top third of the screen, and then if we do I can't do an LDIR because we're going to be writing to an area of the screen that's ROM, so I will do a LDBC comma 4000 CLS part. We can put this down here actually. LD DE comma 0. No, I didn't mean to type that. Some auto-completing nonsense in there. And then if I do so I just think through my commands here. If I do HL here and then do load HL with 0, inc HL stick BC load A. This isn't very efficient, but it'll do. It'll do for now. We'll tolerate this chunky code for now. So that's going to clear from 4,000. I can put that, actually we can put this down here as well. So that's going to clear 1/3 of the screen. You see, if you don't know the if you don't know the Spectrum Next, the way we're working with the Spectrum Next screen here is that the first quarter of the memory map is usually ROM, but with the true color, the 256 color screen mode, we can turn that into the writes will go to video RAM and the reads will do nothing. The reads will work as normal. Okay, that's actually looks like it's cleared all the screen. I don't think it has, but it looks like it has. It's a surprise. I think it's just coincidence. The rest of the screen was blank already. Okay, let's put my joystick reading routine in here. So this is my joystick reading routine. So what we're doing here is we are reading in from the hardware directly. Now, as I said before, Lucas might be interested in this because, as I say, it's not so dissimilar to what you have to do on the MSX. So we're selecting a line of the hardware. Now on the Spectrum, the way you select the line is you move this bit 0 to one of the other spaces. So we're starting with it over here, and then we're selecting the port. The port is made up of B and C on the Spectrum, only C on the MSX. We're then reading in the byte here. We're shifting some of the bits out. The bits will be 1 if the key is up and 0 if the key is down. And so we're just shifting the bits for the keys we're interested in into the H register, and we're having to repeatedly change the B register because we need to use different lines to get the keys we want. We want QAOP space and enter basically. So we're changing B, shifting to the right, which is moving that 0 bit along, selecting different lines of the hardware there. I mean, it's a long bit of code, but the summary is that once it finishes, we will have read in up, down, QAOP, space and enter. So if that's so that's the fire key basically, I believe, if I've done it right. So we're debouncing it there. We're just checking if it's held down so far. There we go. So yeah, so that looks like it's all working, sort of. I mean, we're not moving and we've got some glitching and what have you, but you know, it's a start. Anyway, at least I can finish that clear screen routine now, because we can actually see that it's not finished. So what we're going to do here is let me think it through. Well, we need to recalibrate here. So that should do the second part, and that should do the third part, I believe. No, I've done the wrong one there. That should have been an 8. So yeah, we cleared 2/3 of the screen, but we nearly got there. So yeah, that was because I put C, and that should have been 8. So we have to use get screen pos repeatedly because we can only bank 1/3 of the screen into the lower quarter of the addressable memory area. The screen is it's 48K, and the area we're using to write to the screen is 16. Now usually I use an LDIR, and I kind of I put a 0 in the first byte and use an LDIR to copy that across the range. But because we can write to this area, if we write to this area, we'll get the video RAM, but if we read from it, we'll get ROM, so that won't work in this case. So, I mean, that's not a very good clear screen routine, but it's enough for this. So. So we can't move. I think we need to sort out that control routines. Okay. So anyway, we got graphics on the screen here. I think we need to probably change our sprite routine. Thinking about it. Hang on a minute, where is it? What's the, I can't remember the bottom command. Programming all these different systems, I forget all of my commands here. So we want to do hang on a minute, which is the shift command? SLA, of course it is. Why wouldn't it be? SLA 0. That looks about right. I think that's okay. And then we need to replace these with bit 0, D, and if that is non-zero, that's not up. Bit 1D here, 2D. We're doing very well here, aren't we? Bit 3D. This will be bit 4D, and this will do bit 5D. Why did the border just change colour? The border should not have just changed colour. That's not a good sign. And also I can't move, which... Oh, no, I can. I'm going absolutely crazy. Oh, I know why the border changed colour. It's because I'm using the old specky sound routines. Yeah, okay, well that's fine. I think we're actually done. That's a shock. That was 30 minutes. Should have taken longer. I thought it was going to take longer than that. I was a bit surprised by that. Okay. Anyway, we're not really done. We're gonna do a little bit more work here. So, ironically, we've got to slow that CPU back down because we're running in 7 megahertz mode, which is a lot. So we need to slow down. We need to increase our speed loop. If we... Oh, okay. Now we're too slow. I wish I could cut down that loading speed a bit more. I don't seem to be able to, unfortunately. There we go, that feels about right. Oh. There we go, level complete. Very good, okay. Right, so what we're going to do next then is we're going to have a look at GB Sound. Where is it? Source all. Okay. Yeah, well, you get used to these things. You know, the common code has kind of had all the bugs worked out of it, and I've kind of got used to what problems could happen and things. So yeah, that's the plan. You know, I can't be spending too long on these things. So the benefit of it is, as well as each of these is going to be a separate tutorial for each of the platforms. So you know, as a result of all this programming, I get a little program that I can make a series of tutorials out of. So it'll work very nicely. So yeah, as I say, it'll work quite nicely. I'm not planning at this time to do a Game Boy version because the Game Boy is it doesn't support the same commands, you know, with regards to the XY registers. Now I could make a version using my I've got like an emulation or simulation wrapper that will simulate the missing commands. I could use that. There'd just be nothing recognizable. All of the code would need changing, and I'm not sure at this time that it's really of the best use of my time. So I'm thinking instead of moving on and writing the Tron game. I threatened to make a Tron game for the Z80 systems instead. I think at this point the systems I've covered, except for the Game Boy, I've covered all of the most popular Z80 systems now. I'm not going to do a regular Spectrum version. I don't think the original Spectrum's that well suited to it. I don't think this game, you know, it really wants smoother movement than the tile map, than the character map of the Spectrum can provide. And I think if I cover the Spectrum next, I think if I cover the Spectrum next, the Spectrum fans will be fairly happy with that. You know, I don't think they're going to lament the lack of a regular Spectrum version if they got the next version. I hope not, anyway. Okay. Right, we're getting some slowdowns. There's some jerkiness, but I'm suspecting that's actually the emulator. Okay, so that looks good. Now we're using the AY. We're using the CPC code, which is the AY sound chip, rather than the internal beeper. Now what I'm going to do, I'm actually going to take out that CPU speed change here, because I think we've got more speed than we want anyway. And we'll change the loop here to maybe 100. The graphical routines will be using a higher percentage of the CPU power now, so I don't think we want to halve it, but there we go. We are done now. That was a bit of a shock. Okay, well, we'll finish off. We'll go through the code and we'll comment the changes. I didn't really expect it to go that well. I was actually able to go till pretty much 7 o'clock as usual, so that's very good. But anyway, yeah, job done. So this will be part of the Z80 downloads on Monday. I put them up. I sort of record some videos and I get everything done for Sunday for the patch-ins. I do a weekly update for my patrons, and then so if you come back and check Monday your time, then you should find that the source code for this is in the sources 7-zip for the Z80. So so yeah, if you're interested in this, you can hopefully get it on Monday. But yeah, it went very well. So I'm just going to finish off code commenting the remaining code. I don't know if Lucas is still around. Lucas, if you're still watching, if you reply in the chat, because what I could do is I could go over the keyboard reading routine, the hardware keyboard reading routine, and just describe to you what each part of it does. Maybe that will be a help to you if you're still around. I don't know, maybe you're not interested, it's fine as well. But I just thought to say, if I've got some spare time, maybe if I just go over it in detail, maybe that'll help out. But anyway, until then, we will just finish code commenting the new parts. So I could make this a little bit nicer, couldn't we? Seeing as we've got time. Screen clears a little bit slow. I mean, we could also boost up the processor speed and turn it back down again, but I'd rather leave the processor speed alone. Yeah, that'll do. That's a bit nicer. It would actually work better the other way around, wouldn't it? Yeah, I think this way round will be faster. So if the inner loop uses DJNZ and the outer loop uses the DEC, I think that'll be faster now. Anyway, it's a small thing. Have a good. Well, you've seen everything really, Mark. I mean, the main job was done. So have a good night's sleep. Take care of yourself and get some rest. Yeah, fair enough, Rob. I mean, as I say, I totally understand that, and my work is done. Oh, you've got the next, have you? Okay. Well, have fun with it. Yeah, I hope you enjoy it. I've certainly waited for it. Okay, bank in first of screen. Oh. Yeah, this is an interesting set of modes on the old Spectrum. The layer 2 is quite nice. So the bitmap mode that we're using in this, there's the tile sprite modes, and also there's that weird that low res mode that I can't pronounce the name of, Rastigian or something mode, Rastafarian mode or something. I'm really not sure. It's very, very strange now. I'm assuming it's the name of the person who invented it, but I can't remember it or pronounce it. So, but it looks a bit odd because it's 128 by 96 or something like that, very low resolution. But I mean, it was designed to use the same amount of memory as the original. Redastan, okay. I had a game called Rastascan. It wasn't very good. But anyway, it's a fun mode. It's a fun mode to play with. It's one of those things that makes no sense in the modern world having a resolution that low, but it made perfect sense, you know, back in back in the day on 8-bit systems, and I know it was a later edition. I think it was the ZX Uno that added it, but I just mean, you know, from the point of view of designing around 8-bit limitations, it made a lot of sense. It was quite fun to play with, so I did enjoy it. Okay. So this time we've got 64 bytes per sprite, and this time we've multiplying the x by 8. At least we didn't run out of memory. I was a bit worried. Using the 256 colour mode is far too excessive for this example, but I just thought we'll get it done as quickly as we can. Usually we have to reduce that. In this case, we have to increase it. Let's say the other system, generally speaking, I only target 16 color systems, which is why Yquest Sprite Editor only has a palette of 16 up there. It's got a little extra palette down there, though. Okay. Yeah, I think we're really done here. Let's give it one last go. It still works. That's a good sign. Oh. I was firing down then. I was just wondering why. I mean, it's playable, but it's not as good as the original. It really needs joystick control. Anyway, so yeah. Anyway, it's yeah, so that's that done. So let's have a look. I don't know if Lucas is there or not, but let's have a look at that MSX keyboard reading routine. Might as well. Okay, so here it is. Look at all this mess. I wonder if I'm just wondering if maybe it's got messed up because of the font, but I guess not. Anyway, so let's see what we got here. So the procedure for reading a line of the keyboard is that we need to select a physical row of the keyboard. Now the rows of the keyboard from the hardware side don't match the rows of the keyboard from the user side, so there isn't a line with QWERTY, QWERTY on it in the hardware. If you look at the membrane of the keyboard, the wires sort of dart all over the place because they don't want neighbouring keys to be on the same line really. So the actual hardware layout looks something like this. So you've got, this is each line, and you can see that things don't necessarily make a lot of sense in a lot of places. So that's the hardware layout of the key map. And so when we want to read in, say, the key T, we would need to read in this line. We need to select this line, read in the line, and then look at the bit that relates to the T key. That's what we would need to do. Now, to be fair, I think this is backwards. This is organised for my conversion routine to convert the hardware key map to letters. So the T is actually bit 1 of row 5. And you see bit 1, it's not lined up right, but bit 1 is this one, and it's row 5. So we would need to select row 5 to read in the T key. Now on the MSX, it looks like, I say that because I can't remember, but it looks like we use port AA to select the row we want to read in. And if we wanted to read in the T key, we would need to select row 5. Sorry, yeah, 5. So now the top 4 bits are doing something else. So we're reading in the current state of AA, removing the bottom 4 bits, and then adding via this OR the line we want to read in. Now if we just wanted that T key, we'd have to OR in 5 here. We then write that value back to AA, and so that's updating the currently selected row that we're going to read from the keyboard. We then do an in from A9, which will read in the current state of that row. Now in this case we're just looping through every row one at a time, so we were just rewriting that to memory. But if we were just testing that T key, what we would next do is we would do a bit command or an AND command, and we would just mask the bit 1, and we would see, and if it was a 0 the key is down, and if it's a 1 the key is up. So if the line, all the bits are 1, if it's the line's byte value is 255, none of the keys are pressed. It kind of maybe works backwards to what you'd expect, but that's the way it works. So yeah, that's how you would read in a keyboard. In this case I'm reading in all of the lines into a buffer somewhere. This is multi-platform code, that would be in the common code, but yeah, that's how the MSX keyboard works. It's very common. You saw virtually the same code on every system. I mean, you're basically seeing the same thing here. It's just in this case, it's the position of the bit 0 in the address FE, then whatever that would be. 127 is that? I think it's 127. Now the MSX just uses a single byte for its ports. That's why you can see there's an AA and an A9 here. The Spectrum uses 2 bytes. So that's why they're slightly different there. But yeah, I'd say it's all very common. The for whatever reason, the 6502 systems, they don't work like that. They're all very, very different. I don't know what the reason for that is. Now the 6502 systems don't have out and in commands. They use memory mapped stuff. Maybe that's part of it. But some of the systems they have separate hardware that reads in the keys and things, and then you sort of have to talk to the chips that do that a bit more. So it can be quite like the BBC, or it's very, very difficult to read it, work out what to do. But anyway, so yeah, I thought maybe that'd be of some interest. Yeah, we don't need to save that. So I think if there's anything else we could be doing at the moment. I wrote the joystick and the bitmap routine tutorials for this video today, for this live stream, and I'm going to shoot the videos this evening, I think, and get a few extra ones out there, because there's a bit of a backlog building up. But I think generally speaking, I think that's it. Well, I'm going to end this live stream then at this point. I think I don't want to start doing the... I'm going to start doing that Tron game, but I want to start it next week, because I don't want to try and rush it through today. So thanks everyone for watching. So say if you want that Yquest for the Spectrum Next, you'll be able to get it on Monday. It'll be in the sources 7-zip, and there'll be some new tutorials on the Spectrum Next coming as well, because as I say, I will be uploading these. I will be recording the new tutorials on the simple bitmap example that this is based on, and at some point there'll be the Yquest example where we just cover the code that you just saw. So yeah, as I say, thanks for watching. If you want, I will be doing some gaming tomorrow on the 32X and playing more Dune on the Genesis. So if you fancy that, then please join in for that. But thanks for watching today, and goodbye.